All right. Hello, everyone.
Hey, everybody.
Welcome to another Svelte Summit. Hope everyone's doing well.
We're excited to be back again.
Yes, another season or another year, whatever it is.
Yeah, I guess we do these biannually or twice a year.
Yeah.
So,
Biannual. That's a tricky one, right? Could be
Yeah,
every
it
other
is.
year.
Yeah, exactly. I know. Like the biannual and biweekly, those always like throw me off. I'm like, are we doing them twice a week or every? Like, I don't know.
Well, we do these twice a year, like you said.
But yes, exactly. We do these twice a year, and this is our conference for Svelte. We have a Discord server that everybody can go and chat in the Svelte Summit channel. There's lots of chatter going on already in there. Everybody's excited. There's chatter in the YouTube. We wanted to take a minute and talk about the code of conduct. Do you want me to do that, or you want to do that, Kevin?
Yeah, go for it.
Okay. Yeah, we just want everyone to demonstrate empathy and kindness towards other people today. Make sure you're being respectful and just put out into the world what you want to receive yourself. Don't be mean to people, and make sure we keep the chat clean. And let me give you that link again. I did post it earlier, but I will post it again for everyone to look at that. And I think that's
Cool.
it.
Yeah. So also before we start, I wanted to thank our sponsors. So we partnered this year with a company called Convex, and they have provided a talk for us as well, which we're going to see later today. So stay tuned for that. And then as well, of course, Monogram, always sponsoring Svelte Summit. Really appreciate it. Really makes it work. So yeah.
They have been great supporters of the Svelte community, and we really appreciate both of them, Monogram and Convex.
Yeah. All right. Do you want to talk about the first talk?
Yeah, absolutely. So we are going to have Gaitan Boisson do simple and sustainable web development in academic libraries with Svelte. That is a big mouthful, but basically the libraries at the National University of Singapore, which is like incredible that this has happened. They've chosen Svelte as their framework to develop small custom projects to showcase selected parts of their collection in an engaging way without straining their resources, which basically what we use Svelte for anyways, right? And so one recent example was the migration of a collection of historical maps to a fully static site powered by Svelte and Astro. In the talk, we will see how Svelte makes the development of rich interactive websites easy enough for librarians to tackle it, and how it makes maintenance trivial. So I am excited to hear more about this.
I did not expect to see a talk about like libraries using Svelte, but here we are.
Right? Yeah.
Yeah. All right. So without further ado, here we go.
My name is Gaëtan, and hopefully this presentation will be a bit different. I am not a developer, but a librarian at the National University of Singapore. I am in charge of the digital scholarship team, where we work on showcasing our collections and the result of the research done at the university in a fun and interactive way. It's not all about books here, and today I am going to tell you about our map collection. Let's have a quick look at our site first. So we have a base map showing contemporary data from OpenStreetMap, and it's using all the standard gestures we know from using online maps. Here, we have a list of maps that were digitized by our Department of Geography, and we can choose the maps we want to display. So let's have a look at this map from 1966, for instance. You can see that it was made of a few sheets of paper. Each one was georeferenced so that it would properly be layered on the geographical coordinates, and we stitched the result together for display. Singapore is a country that evolved really fast, so it's very interesting to compare the shape of the coast, for instance. Here, you see that the whole Marina Bay area, which is very developed today with landmarks like Marina Bay Sands and Gardens by the Bay, actually sits on reclaimed land, and the area was covered with water in 1966. If we look at this map from 1974, we can see that the coast was already starting to change at the time. And if we go further to 1983, at the time we even had more development, and we can see we had infrastructure like roads and bridges that were already built. Now, what I like the best is look at older maps. So we can look at 1914 here, and I really enjoy looking at how things looked like back in the past, and especially how places had different names. I think you can all see how valuable such a platform can be. Now, as librarians, of course, we are very focused on preserving our data and making it widely available and reusable to the general public. If you aren't familiar with geospatial data, you have to know it is a very peculiar beast to work with. This is a screenshot from QGIS, and you can see there are literally dozens of different competing formats. And you can see in this screenshot, we have more formats than there are JavaScript frameworks to choose from. And we aren't even going to cover anything regarding projections or coordinate systems today, thankfully. The main issue we had here was that geospatial data can be quite difficult to manage. The usual stack for this kind of project involves a dedicated server running specific software like Map Server and maybe even something like Map Proxy on top of it to speed up the retrieval of the image data. This meant a pretty heavy maintenance overhead for us, and so we designed a fully static architecture that does not require any of this. We transformed all our data in a format called Cloud Optimized GeoTIFFs that contains the whole tile pyramid of each layer, and our interface is using HTTP range requests to fetch the relevant parts of the image rather than the whole thing, which would be very slow. We use Astro to generate the web pages themselves, OpenLayers to manage the map, and Svelte helps us with the whole application logic and interface. Now, what is so great about Svelte is that it is surprisingly close to JavaScript. It provides us everything we need to build a nice interface, but it will stay out of the way when we're using vanilla JavaScript libraries, which is perfect for someone like me. Since we needed to use cloud-optimized GeoTIFFs for storing our data, we required a mapping library that works with them natively. This is how we chose OpenLayers to implement our map. Unfortunately, there is no pre-existing Svelte wrapper for OpenLayers. So let's have a look at how we created a handful of Svelte components to display an OpenLayers map. We chose to leverage the Context API, which allows us to weave things together. Svelte context is not reactive, but it will allow us to share an object with the children of our parent component, and in this object, we are going to have Svelte stores, which will bring reactivity to our application. Here is the file where we define how our context will be created, and you see the function will return an object with a handful of Svelte stores. Here, we are looking at the root component of our application. You see it accepts basic props to set the latitude, longitude, and zoom level of our map, and has two child components. One is the base map, and one is the interface. Let's have a deeper look at our OL map component. You see it uses the create map context function we defined, and this allows us to share reactive stores with the child components. Further down in this component, we use onMount, instantiate the map from OpenLayers, and make it available to other components through the context. Here, we are looking at the base map component. After getting the map instance from the context, it simply adds the OpenStreetMap layer to the map, using basic features available in OpenLayers. As you saw earlier, the other child component was the map interface itself. So this is the component that will be in charge of adding the other layers. To make things smoother, we are lazy loading the maps when the cursor goes over a link, using Svelte features like the once modifier and the pointer enter event. And here, we use Svelte's conditional rendering to add the layer once we have detected this event. This was a quick overview of what we did for our project, but I hope it shows you how easy Svelte made it for librarians to code this platform. Thank you for your time, and I hope you will enjoy exploring our maps and our repository.
All right. Sorry about the audio, everyone. Hopefully the post audio thing didn't blow out everyone's ears when I turned that on. I tried
It's so
to
hard to
smooth it in.
Yeah, it's so hard to deal with audio too. Like the recordings come in a little lower if they don't have the volume boosted on their end. We max it out on our end, but then you get the loud transition. So it's a
Yeah.
difficult balance to strike. But that was an amazing talk. I had never heard of open layers before, so I am excited to kind of like dive more into that. That was really cool.
Yeah, same. Like really, really cool. Never thought I'd see like that use case as well. Like
Yeah.
putting maps on top of each other to see like what did it look like 50 years ago or whatever. So it's
Yeah.
really nice. All right. Next talk we have, let's see here. It's Joshua Nussbaum. I think that is how he pronounces his name. I guess we might see in the video. So this talk is called Building a SaaS Module for SvelteKit. And so it's about how he turned a failed startup into a reusable SaaS module for SvelteKit. So a deep dive into adding a Stripe integration to Auth.js using the SvelteKit hooks. So yeah, here we go.
And welcome to my talk about building a SaaS module for SvelteKit. So first, a little about me. My name is Josh Nussbaum. I am a developer using Svelte in Montreal, Canada. I'm Josh Nuss on GitHub and Twitter if you want to follow me there. And so the talk today is going to be about this new thing I created called AirBadge. So what is AirBadge? The purpose of AirBadge is to help people start their SaaS. So normally a SaaS takes a lot of work to create. Sometimes you need to do multiple attempts because we're developers, we don't really know marketing and sales and all that jazz. So it can take multiple attempts to get going. And so my tool is designed to help people with SvelteKit quickly create their business and start experimenting. So I divided the talk into three parts. The first part, I'll go into the reasons why I built this project, what it is, like how to use it, and then the actual implementation. We'll go into how it was built. Cool. So first, let's start with why. What's the motivation for creating this? So back in 2021, I created this Svelte app. This is actually before SvelteKit, called Carrier Wave, and it was a SaaS that was for e-commerce companies that wanted to monitor their warehouses to make sure their packages were leaving on time. It had some moderate success. It was the first time I actually made some MRR online, which was really cool. But ultimately, after a couple of years, it kind of like tanked out a bit and ended up, I guess, kind of failing. But, I was thinking like, a lot of people usually use the term win or lose, but I kind of like to use instead win or learn, and try to see like what can I learn from this project. So I was kind of like thinking to like mine it for ideas, like what ideas can I take out of it that would have made it easier to build. One thing that came to mind was that when I launched this SaaS, I skipped creating payments. It might seem weird to you because I have a lot of payment related projects, but I kind of figured like to me payment was like a chore. So like I figured, I could just add it later. I'll instead let me focus on building features. And I kind of like just had like a verbal agreement with the customer that they would pay me, send them an invoice or whatever. Um, it kind of didn't turn out well doing that because I feel like payment is a very important signal your business needs to get. Whether you're not getting payment, which could be a useful signal too, because that means you may need to add some more features, or if you're getting payment, right? Like the engine of a SaaS is that it provides a feature for a customer, they pay money, and so on and so forth. So if the payment isn't working properly, you're kind of not validating your idea. So that's why I think it's really important. Now, I did look at other options. This isn't the only, what I'm going to present to you isn't the only way of doing things. There are other alternatives. A very common one, of course, is you just do it yourself, right? You just code it, integrate Stripe, integrate authentication. It's not that hard. It maybe takes a week or two. I mean, especially like me, if you want something that's going to be quality that has tests, it's going to take more time, right? So for me, it's probably a week or two. It's just that, like when you're starting your project and you're excited about working on it, like the last thing you kind of want to do is like now start working on this chore. So that's the only reason why, I prefer not to do it myself if I didn't have to. Another very common approach is using a starter pack, right? So these come with like everything pre-configured, and it's they're useful, they're helpful, right? But the problem is also you end up with this giant code base, right? That's designed to help so many people that it has way too many features in there, and it's hard to match the stack. Let's say you like Svelte. Well, a lot of starters are using Next.js. A lot of starters, maybe you like Tailwind, and it's not using Tailwind. So it's hard to like align the stack well. And I think it's important to have a stack you like, right? Because after all, you're going to be in this code day in, day out. Like, you really should enjoy. You shouldn't be annoyed that you have to go work with this thing you don't like. There is another alternative, which is obviously we can use a cloud. There's some cloud offerings like Memberful and Outseta that provide services. But if you're going to be successful, you're looking at probably thousands of dollars a month to use these services. So it is kind of expensive. Your money will go flying away. And then, or you could do my mistake, which what I did, which was basically say, you know what, I'll do it later. And as we discussed, like, you do want that signal. You do want to know positive signal or negative signal. Either way, it's a useful thing to know if your thing is working or not. So now let me show you the solution that I came up with. And what it is it's basically a wrapper around Auth.js. I don't know if you guys are familiar with Auth.js. It's a project from Vercel that provides authentication for SvelteKit. And so this wraps around Auth.js, and it adds an integration with Stripe. So Stripe will handle the payment, and Auth.js will handle the authentication. And you join those two together, and then you don't have to really write much code. So it's super fast to set up. So like basically you're removing a week or two of work. It's a library. So unlike a starter, it's easy to update. You can just take the latest version and the fixes will be in there. You don't have to pay for an API or anything like that, or worry about doing it yourself, which I think is awesome. And it's open source, so you can open a PR, fork it, change it, read the source. It's all there, which I think is super important if it's something your project is depending on. It's also free. So I do plan to have a paid tier, but my goal is to have something that is designed for experimenters, for people that want to try something, this weekend or next week. And I don't think we should put like a big cost in front of them to do that. But it's going to take multiple tries for them to build their SaaS. So when they get successful, then then there'll be a charge coming in maybe. You end up with a lot less code this way. You don't have to maintain this giant starter pack or anything like that. You're with just a couple lines of code, you have a SaaS. And you don't need to write all that testing code. So it's a tested library. You're going to save a ton of time avoiding doing that. And the main goal being to make it easier to experiment, right? So let's look how we would set this up in a SvelteKit project. So in your blank SvelteKit project, you would install the airbadge/SvelteKit package. Then you would go into your hooks and you would configure, this is your global hooks that runs on every single request. You would use this SvelteKit auth that's provided by the package, and you just need to give it a little bit of configuration. Now the configuration is quite similar to Auth.js, just a couple of differences, which I'll go through. Now you do have to figure out your database. So Auth.js supports many databases, Prisma, Drizzle, but you do need to adjust your user table and just add some columns. This is just to track the Stripe customer ID, the plan that they're on, and the status of their payment. And then once you do that, you can specify in the hook server which adapter you're using. Now, in this case, I'm using Prisma, but like, for example, if let's say you use Mongo, you wouldn't even have to do any schema changes because Mongo is schemaless. So the new attributes would be added the first time you use them. Okay, so now that we have our database set up, we can set up our authentication. Now this is up to you. Some people want to use Google OAuth, Apple OAuth, GitHub, passwords, passwordless. All of that is supported by Auth.js. This is just using Auth.js, so you use any of their supported versions. And then you would go ahead and you would create your pricing. So in Stripe, you could set up products and pricing. And in our case, we want to set up a price for a subscription. So you could use the dashboard. I like to use the CLI just because a lot of times in your SaaS, you'll have like 3 prices. So it's nice to have a script that could set that up. And here we have we'll create a price for a basic plan. We'll say it's $10. That's in cents, so $10 per month. And then once we do that, we get a price ID, and we could then put that into our config. So here's my config. I will just say plans, and I will specify the ID of that plan and what the price is in Stripe. So this is the code we got from the last step, the ID we got in the last step. And once you do that, you end up with something like this, where you have on the left a UI provided by Auth.js where user can log in. Now, the first time they sign up, let's say I click on a Google sign in, I'm going to be redirected to pay. So that will happen on the first sign up. And the user will come back to SvelteKit with the access token. Now, AirBadge also will handle all the Stripe webhooks for you, so you can use the Stripe CLI again to, even in development mode, you can forward all the webhooks to your local host. And this way, if somebody changes something, let's say in your Stripe dashboard, you cancel a subscription, it'll fire off a webhook, and that webhook will get forwarded to your local host. So it's a good thing to run this in development mode. And now a very common thing is that you want to have conditions based on the status of their subscription. So the nice thing AirBadge does is it adds some extra data into the session, and you'll see now there's this extra object called subscription. So I can make a conditional here, like, oh, if the subscription plan is Pro, then do something that only Pro plan can use. Or if the status is trialing, the payment status is trialing, then they're on the trial, and we can do something differently. So this makes it really easy to write to gate areas of your code base. And you see here on the right, the gray stuff, this is basically what is in your session. And the gray stuff is provided by Auth.js. And the purple stuff is what's provided by AirBadge. So the extra plan and status and all that stuff. Cool. So now I'll go a little bit deeper and show you guys how I actually built this thing. Obviously, it's built on top of Vercel's Auth.js. And Auth.js provides a data model that looks something like this. So this is what your database schema looks like. It basically gives you a list of users, and it has a one-to-many with accounts. So I think the accounts is more like credentials. So like imagine if a user has an Apple ID and a Google ID, they would have two records in the account table, one for Google, one for Apple. So that's how that works. And the adapter, the database adapter, is basically just an interface. Like you can write your own. They have tons already, Drizzle, Prisma, Mongo. But all it is basically a bunch of these functions that are either creating, deleting user records from the database. So AirBadge is just reusing these. And then there's also what they call providers. These are like authentication providers, and they support many types, including OAuth, credentials, WebAuth, and there's tons and tons of options. I think there's almost like 75 or maybe 100 options. So very flexible to use. And Auth.js also provides a bunch of endpoints, and they're under /auth. So these are useful endpoints you can use for authentication. So imagine you want to sign in a user with Google. You could create a link on your site, like it looks like a button. It says sign in with Google, and you could just point the link to this /auth/sign-in/Google, and that'll sign them in with Google. Or if you want to create a sign up button, you can just have a link that links to sign out. So these are like handy utilities for authentication. Auth.js also allows you to customize where things go. So for example, you want to change where the sign-in page is, or you want to say like when a new user signs up, where to take, maybe you want to have a welcome page. So you could change this to say /welcome. So you can configure, it's all very configurable. And it also lets you hook into the life cycle. So it has a thing called callbacks, kind of like hooking into different parts where you can say like, oh, when somebody signs in, you can have some logic here. Maybe you can check, oh, it's the first time they're signing in, send them a welcome email. Or so it's quite customizable. Now the other side, so one side is Auth.js. The other side of this is the Stripe integration. So typically a Stripe integration with SvelteKit or with any JS project, you either have two options. You either can use Stripe Checkout, which is kind of like a hosted version where the UI of the payment is all handled on Stripe, on Stripe's domain. Or you can use Elements. Elements are kind of like little widgets, little payment like a credit card form or things like that you can embed into your SvelteKit app. And so if you want to try out Elements, I highly recommend checking out this project, sveltestripe.com. It's created by me, and it's sponsored by Stripe. Thank you, Stripe. In this case, AirBadge is actually using the hosted checkout. So what that looks like is kind of what you see on the screen here, where you would basically say, using the Stripe client, you would create an object and you would tell it like the currency, maybe USD, the line items, like which products or subscriptions you want to pay for. And then it gives you back a checkout URL, and you can just call SvelteKit's redirect function to send them to that URL. And Airbadge also adds a bunch of endpoints, similar to how Auth.js had /auth. Airbadge adds /billing. And these are, again, a bunch of utilities related to billing that you can use. For example, if you want to check out on a specific plan, you can just make a link. Like imagine you have a pricing page, you can say buy now, and the buy now could link to /checkout plan equals pro, and then that'll sign them up to the pro plan. Or you can, let's say you want to have you want to upgrade, you want to have a button that says upgrade plan. You could just have a link to /modify plan equals and the new plan that you want to upgrade to. So these are very easy ways to build utilities, billing utilities into your app. Now, what about monetization? I did say that I'm hoping for this to be very usable on the free plan, but I'm thinking also there may be like a higher tier, maybe like some paid pro features. The idea being mostly like, I think like if I was using a project like this, I would want it to be maintained and well supported. And so that's sort of how I'm thinking about it. We're going to see it'll probably be team features or something more like for a high-end B2B business. I'm going to use the BSL license, which means that other people can't sell this. So I have the option to sell a paid version. And after a certain amount of years, it reverts to MIT license. So it just gives me a chance to be able to offer a paid version. And so what's next for this project? Well, in talking to people and getting like initial feedback, one thing I think that would be really cool would be to have a hosted version. So imagine having a subdomain on your domain called auth. Whatever your domain is. And this would open it up to a lot more frameworks. So imagine somebody using Next.js, they can still use this, or .NET or Python or whatever. They could just host it in a Docker container or deploy it to Vercel, and they don't have to know Svelte to get the benefits of it. Another feedback that I got from a lot of people is that sometimes people aren't selling subscriptions, but they're still selling things that are connected to the user. For example, digital content, like if you want to sell videos or ebooks, it would be nice to be able to buy them through Airbadge and just have the access token say what the people have access to. So that's something that is going to be coming as well. All right, so in conclusion, I'm hoping that Airbadge will help people create their business, that it will help them experiment more and faster and even fail faster, because I think failing faster is how we get to success. So hopefully that can help you do that. But thank you very much. I appreciate your time. I'll just share with you guys some links. If you're looking for any help with this project, you can hop onto the Discord. We also have a very good doc site, or you can check out the code on GitHub. All right, guys. Cheers.
All right, we are back. That was a great talk. I hope our audio is lower now.
Yeah,
So,
I lowered mine too. So
yours is very loud.
loud? Is it too
Yeah.
loud? I'm turning it down.
Very,
Is
very
it
loud.
better?
I think you can turn it down even more.
It's a half now. Is
Okay.
mine-
Oh, that's better.
Okay. Sorry about that. This thing is finicky. I have a Yeti, and it's like it's really quiet. So it's not as loud as I would like it to be. Good. I'm glad the volume is better for people. I see people saying better in the chat. I was going to say that was an amazing talk. I did post a couple of different repos over in the channel, the thread that we have in the Svelte Summit channel. The first one that I posted was just a SaaS SvelteKit example. And then there's the Air Badge example that he posted at the end of the talk that everyone can see the links at the end there. So yeah.
Yeah, nice. All right, so yeah, we're it's time for the next talk.
All right.
Do you want to go ahead and present?
Yeah, absolutely. So now we have Sean Lynch coming to intro us to LayerChart, which I'm very excited to see this talk because this is kind of a component library, but it's a component library that builds visualizations for charts like Cartesian, radial, hierarchical, I can't say that word, hierarchical, and geographical, like maps and charts and things. And so I'm really excited to see the intro to LayerChart and how we can use it in our Svelte and SvelteKit apps.
Yeah, all right, so here we go.
Hey everyone, my name is Sean Lynch and I'm the creator of Svelte UX and LayerChart. Today I will be providing an introduction to LayerChart. The agenda of the talk is first starting with a brief introduction about myself and the project, including how it got started. I've prepared a little demo reel to show what is possible with the library. Then I'll break down how LayerChart works and finally deep dive into a few examples. As I said, my name is Sean Lynch. I'm a developer who lives in West Virginia in the United States. I was previously a contributor to Vizix, a React visualization library. I'm currently a lead software engineer at Definitive Healthcare, working on a healthcare analytics project in the med device space. I'm fairly active on Twitter and Discord if you want to reach out and say hello. Both Svelte UX and LayerChart also have a shared Discord server if you need any help or just want to chat. Invite links are available on both projects README. A brief history about the project. I started working on a new healthcare analytics startup in 2017, originally written in React, and we use Vizix for the visualizations. For those who may not have heard of it, Vizix is a collection of reusable low-level visualization components for React. Vizix is what got me drinking the compositional chart component Kool-Aid back in 2017 while watching Harrison Schaaf's early live streams. I contributed a few PRs to the project, including their text component, a lot of hierarchy components, including tree map and link, and assisted with the design of XY chart and React Spring integration. During the summer of 2020, I decided to switch my primary project from React to Svelte after drinking the Svelte Kool-Aid, as I like to call it. Svelte solves so many issues we have been experiencing on a mature React project, and is especially adept at making highly interactive visualizations. LayerChart was created as a means to fill the hole left by Vizix. At the time, I also came across Michael Keller's LayerCake library, which aligned with the work we were doing with XY chart and Vizix, but even more integrated. At this point, I decided to create LayerChart from what I had learned from the developing and using Vizix, the internal chart library we had built upon Vizix, and using LayerCake's foundation and robust examples. Later inspiration also came from Observable Plot, and was created about a year after LayerChart. Both LayerChart and Svelte UX are used on two robust healthcare analytics projects, as well as many others. Now let's take a look at the demo reel to get a glimpse at what is possible with the library. LayerChart would not exist without standing on the shoulders of other open source projects. D3 provides a robust collection of utilities, ranging from scales to shapes to layouts, although this is truly an understatement to its importance. Moving up the foundation, LayerCake is responsible for setting up a chart's context, including the dimension scales as well as the rendering layers, which we'll be delving into further. Lastly, at the top is LayerChart, which sets up additional context including tooltip and geographic projection, and provides all the components ranging from drawing primitives, data-driven, interactions, geo, layout, and others, and we'll be delving into many of these. Practically all JavaScript-based visualization libraries are built upon D3, including LayerCake. Popular React libraries such as Visix, Recharts, and Nevo, and framework-agnostic libraries including Observable Plot, which was also created by D3's creator, Mike Bostic. You'll even find integration within Tableau and Power BI applications. Now let's talk a little bit about the chart structure and get into why it's called LayerChart. At the root is a LayerCake chart. You pass the data and describe each dimension or axis. For this example, each item in our data has a date property that is used for the x-axis and value property for the y-axis. You may also define additional information when setting up your dimensions or scales. For example, we define that the y domain should start at 0 regardless of the smallest value, and null is used to have LayerCake determine the max extent for us. Padding is also useful to provide space for an axis or legend. Lastly are the different rendering context layers. LayerCake supports SVG, HTML, Canvas, and WebGL layers, each with their own strengths and weaknesses. These layers are stacked atop one another, and any combination can be used. You may also use more than one layer of the same type, which can be useful when dealing with Canvas contexts. Each rendering context has its own strengths and weaknesses. Here's a general guide of reasons where I believe a layer excels or struggles. Since both HTML and SVG add elements to the DOM, they excel at styling and interactivity, since you can leverage CSS, including variables, and element events, such as mouse over and click. They are also generally the easiest to work with and familiar to a web developer. HTML has the advantage of layouts such as Flexbox, Grid, and the general box model, while it has limitations with graphics such as rendering a complex path. Typically, it is also the best option to use when rendering text, since it is the only context which supports native word wrapping. SVG is typically the most common layer due to its robust graphic support, it's kind of in its name, has all the benefits of the DOM, and while it lacks word wrapping, it makes up for it with support to apply text along a path. While the DOM giveth, it also taketh away in the performance department. Due to the overhead of tracking each element, very complex visualizations such as when there is a lot of data or have detailed paths can bring the browser to its knees, especially for mobile or less powerful devices. This is typically where I find it best to reach for Canvas or possibly WebGL. While Canvas lacks direct interactivity, sometimes leveraging SVG in limited aspects along Canvas can provide the best of both worlds. Lastly, WebGL typically provides unmatched performance at the cost of an unapproachable API via shaders. My rule of thumb is to use SVG as much as possible, falling back to HTML when layout or text become challenging, or Canvas when additional performance is needed. Luckily, LayerCake and LayerChart allow you to mix layer types, and some of LayerChart's components even detect the context it is within and use the applicable API under the hood, such as the GeoPath and GeoPoint components. This is an area I also plan to continue to explore in the library. Now I'd like to give you a tour through the documentation and kind of how best to leverage it and what's available. Along the left-hand side is the nav menu, and we have a getting started section, both if you're using Svelte UX as well as standalone. So it does work with other libraries like Skeleton or ShadC and Svelte or Daisy UI, or even other CSS libraries like Uno CSS. We also extract out the changelog, and then we provide a pretty large, robust collection of examples. They're grouped by kind of chart type. We have Cartesian and polar for just kind of your general, X, Y, or radial type charts. We then have hierarchy and graph, followed by force components or force examples, and then geo, which is maps and globes. And then below all that is then the components themselves that make up those examples. So these components are grouped based on their functionality. And while some of these could probably span multiples because they kind of are dual or triple purpose, they are kind of grouped into like where you might find it the best. So common is, as you'd expect, the most common components that you'll reach for in typically most, if not all, of your visualizations. Chart being the thing that you'll always reach for, along with things like an axis, as well as like a legend if you want to show like a color scale or kind of a breakdown of your scales. Next are primitives, and primitives are basically SVG elements that have been enhanced with motion capability. So they support both tweening and spring, and they also support the theming that's built in kind of out of the box. So while you can still leverage like a standard circle or a rect or just another common like lowercase element, you typically will probably want to reach for these just because they do integrate well, and most of the examples are using these. Next up is the data-driven components. And these are context-aware to the data registered to the chart, and they kind of marry that data with the primitives themselves. So these are what you'll reach for typically the most to go along with your chart. And they leverage the primitives under the hood. And you might need to kind of break glass on occasion and like override a slot, which is available for many of these, and use the primitives. But typically the data-driven ones are very flexible in what you need to do with them or what you'd like to do with them. Next are interactions. And these include things like tooltips, dragging a canvas around, for example, like a map, or maybe you have like a large collection of like a scatter plot that you want to like drill into. That's something you'd use with like transform. But these kind of have all to do with like, either hovering or clicking and dragging or, some type of interactivity. There's also a new brush component coming as well that we might take a look at later. Geo, as you'd expect, is where all the geographic-based components are for building out maps and globes and whatnot. Followed by layouts. Most of these are hierarchy-based layouts, as well as then the force simulation. So as opposed to using the data and plotting it into like a XY coordinate system, you use these layouts based off of the structure of that data and or registered forces for force simulation, and it will put the elements accordingly based on that layout. Next up is clipping, and this is kind of everything to do with clipping. Anytime you want to various ways that you might like clip something to be invisible. A good example of that is clipping a geo map, like a tile, to the boundaries of a geographic region, for example, like the United States. And we'll take a look at that here in a minute. And then lastly is the other section. And this is just kind of a misfit toys section, so to speak. These don't really fit well to kind of warrant a new category just yet. Some really popular ones in here are like linear gradient and pattern to add some styling to your SVG elements. And then things like motion path to animate a element along a curve or a path. Let's take a look at how best to leverage the documentation. So I'm going to scroll up here to kind of a random component. Let's see. Let's use spline. So we have our navigation on the left. You can also jump to a component by either clicking up here or hitting Command K, and then filtering down to say, for example, like bar or globe, if you want to see kind of like all the globe examples. So that's kind of jump around. Once you're in a component or an example, at the top there's the description. There's the source. So this is the source of the component itself. If we're looking at a component, not an example. From here we can also click on View on GitHub, and it will jump us to the GitHub page, which can be useful if you want to reference some lines in here and copy this URL off to somebody. Going to close this out. Along with the source of the component itself, there's also the documentation or the page source that we're looking at. So same capability. You can scroll through and kind of see like how everything's made. It's particularly useful to use this to like look up in the script section. And then same thing, you can click on view on GitHub and do the same thing there. We also have on this page, which is the little table of contents on the right. You can toggle that away if you want to kind of go full screen. This will also collapse responsively on smaller viewports. As we kind of work our way down the page, there's usage, which is kind of just like how to import it. Each component is a little different, but some will have a playground to kind of give you a lot of examples that you can kind of play with within here. Typically, the components themselves are fairly light on examples, but they'll then point you to kind of a more fleshed out, like actual example kind of towards the top of the page up here. So we're just going to scroll through here and we can, play around with some of these examples. We've got tweening for the spline, how to document beginning and end of the points, and even like, synchronizing the drawing of a line with a dot. So then we get to the section called related. And this is helpful to both find related components. So if, for example, this component doesn't fit your needs, you might find another component that aligns better, as well as then the examples for that component. And this is usually the most useful to kind of bounce between examples and then the documentation itself of a component. And then within the documentation of a component, we show you the API that we kind of extract out, including its slots and its events. And that's really useful. So let's go ahead and jump to one of these examples like Sparkline. So if we click on this, this jumps us up to the Sparkline. And now we can kind of see a little more like fleshed out examples. For example, like if we use this spline kind of inline as like a spark line with a very small, height, which basically turns into a spark line. And each of these examples, both within the components as well as the examples, you can see the code specifically for this. And that's kind of where it is useful. Sometimes you want to look up in the page source to see kind of what's in the script section, kind of encompassing everything. But when you just want to just kind of get a general idea of what's going on, that's available here. For each of those, you can also view the data that's kind of being passed to the underlying chart. So this information right here is the data that's being passed to our chart right here. Now there is some serialization involved when you pull this up, and particularly when you go to copy it. So for example, dates will become stringified dates as opposed to being date instances. So you kind of be a little wary of when you pull that it may not be 100%, but it should get you pretty close. So we have the ability to copy the data here. You can also, when you're looking at the code, you can copy the code example. If you're looking at page source, you can also copy the whole page source. If this is sometimes a good way to get started. The documentation does use local aliased imports. So one thing you'll need to do when you do copy and paste one of these is you'll need to update the kind of internal imports to just the top level layer chart. That's actually outlined in the getting started section, if I'm not mistaken, towards the bottom. Yeah, right here. So the examples kind of tells you, if you see this, it should translate into that. Let's go back to Sparkline here for a minute. And if we scroll down this example, you'll see that there's related components. So we can see that spline and tooltip and highlighter related, as well as maybe if this doesn't fit your needs, there might be another component or example that does. And that's kind of like what Spark Bar is doing. It's showing you a similar example, but using a bar chart as opposed to a line chart. So that's basically the documentation. At the top, we also allow you to change the theme. So you can switch between light and dark mode, and I apologize for the flash for those watching this. Switch back to dark mode, and you can jump between dark themes as well. These themes leverage Svelte UX themes at the moment, but you could also, this should work fine with, for example, Skeleton or another theme library. It just uses CSS variables underneath the hood and basically Tailwind classes. We also have a link to our Discord server, so if you just have some questions or want to chat about it, that's the place to kind of go from there. We also have our GitHub repo and its issues. So if you want to file an issue and if you prefer to, even just have discussions through that works. There's a link to my Twitter X page where I post a lot of kind of updates as they come out. And then also a link to the companion library, Svelte UX. I appreciate you taking the time to listen to my talk. I encourage you to explore the documentation and try out the library, and let me know what you think, as I'm always looking for ways to improve it. If you browse the issues on GitHub, you'll see the project has a lot of enhancements planned. If you liked what you saw, I would love for you to start the project on GitHub, follow me on Twitter, or join our Discord server, or maybe all three. I'm always on the lookout for feedback or more contributors to make the project even better. And lastly, I hope you have a wonderful day.
All right. That was amazing.
That was so good. And there's been so much love in both chats for that talk. I'm so excited about that library and checking out like Svelte UX, and I want to work more with all of this stuff. It's awesome.
Yeah, I particularly like the comparison table with the HTML, the SVG, and
the one that tells you like what it's best at for each level or each different type of thing. Yeah. I was surprised by performance. Like the HTML was the worst performance.
Right.
Like that's built for the browsers, people.
Yeah. I mean, it surprises you sometimes, right?
Yeah, it does. Yeah. It was awesome.
All right. Next talk. I think I'm presenting this one. So
yes.
Next talk is called Spatial Programming with Threlte Studio. So I kind of teased this on Twitter earlier today. So if you've been following the Twitter, maybe you know what this is about. But yeah, let's read the description. Sorry about that. What if you could move your Svelte components in space as if they were real building blocks? So Threlte is a framework for rapidly building 3D web apps in Svelte, but 3D scenes are inherently visual, right? And arranging them by modifying props is tedious. As much as we love our editors, sometimes they aren't the right tool for the job. Join us for the unveiling of the Threlte Studio, a graphical interface for editing hackable 3D scenes. Tweak position, color, size, and many attributes more visually in the browser. And the props in your code are adjusted. Move back to your editor to write some logic. No proprietary data formats, just you moving Svelte code in space. So here we go.
Hi, my name is Grisha. I'm a full-stack software engineer with a front-end focus. In 2022, I created Threlte. Threlte is a framework to create interactive 3D web apps with Svelte and Three.js. It's not only a framework to abstract Three.js, but it also aims to enable an ecosystem of packages. For example, there's Extras, a package that houses over 50 of the most common abstractions to load models, play audio, draw text, or lay out your scene. Then there is GLTF. The GLTF package is a GLTF to code generator, which improves the GLTF workflow. There's Rapier, which integrates the excellent Rapier physics engine with Three.js. There is Theater, which integrates the Theater.js animation framework. And then there is XR, which makes developing XR-enabled apps ridiculously easy. There's Flex, which aims to resolve the lack of native WebGL UI layout engines in Three.js. But ultimately, what you do when you use Svelte is that you write code. The output, however, a 3D web app, is inherently visual. In all my previous Threlte projects, I carefully and tediously edited props by hand, going from code to browser, back to code, back to the browser, and so on. What if we had the same what you see is what you get editing experience that we know from the HTML dev tools, but then for Three.js and Threlte? And today, I'm excited to share with you Threlte Studio. Threlte Studio aims to bridge the gap between the browser and your code. Threlte Studio is a scene inspector and editor. The changes you make are reflected right back to your code without the use of a proprietary data format. When you build for production, the studio just vanishes. There is no runtime dependency. Because we made sure that it easily integrates with existing Threlte projects, you can opt in and out anytime. It's also fully extendable, and it comes without bogus install fees. But enough of the talk, and let's have a look at an example. Here we see a very simple Threlte scene, Threlte setup. It follows the best practices that we recommend, and that is having a single scene component wrapped in your canvas component that Threlte is exposing. Inside of the scene, we see that it's a rather simple scene also. It's a camera, which is made the default camera. It's 2 lights, it's 1 cube, and a cylinder, which acts as the ground. This is what the scene looks like in the browser. To use the studio, you just wrap your scene, your whole scene, in the studio component. The other thing that you have to do is you have to go into your Vite config and add the studio plugin to run before the SvelteKit plugin. Now, when we go back to the browser, we see that there is a lot more happening. We have a toolbar at the top, a scene hierarchy, and a viewport gizmo that tells us the orientation of the camera. Let's have a look at the tools that are in the toolbar. So first of all, if you're a little bit familiar with apps like Blender, then some things will be familiar here too. You can switch between local and world transformations. You can enable and disable snapping. You can switch between tweak selection and box selection of objects. You can translate, rotate, and scale objects. You can switch to an editor camera. You also see that there is another pane opening up down here, which is the main camera that we are rendering it to. You have the ability to focus on a selected object. You can view everything as a wireframe, as a so-called matcap material, or as the final rendering. You may also disable and enable the grid or various helpers for camera, slides, and other things. One thing that I mentioned is that the studio can write changes back to your disk, back to the code. And this is what you can enable here, the sync settings. You can have it on auto. That means that any change that you do is automatically written to disk. Or if you prefer a little bit more control, you can leave it on manual. For now, I leave it on auto. Any change that you do to your objects are undoable and redoable. Currently, there are 2 ways to edit an object. The first one is to select it in the scene hierarchy and use the inspector to modify properties. And the other one is to use the gizmo to translate, rotate, and scale an object. You also see that most of these tools, they have hotkeys attached. So translate, rotate, and scale. Now, what I'm going to do is to get that cube up a little bit and watch what happens to the cube mesh when I'm doing so. So I'm dragging it up and letting it go. And you see that the position prop was automatically added to the code. And because these changes that we do, they are written back to the code in the form of props and not as a proprietary data format, we can easily check it into our version control system and always have a consistent project state. Now let's see how I can make this demo scene at least a little bit interesting. So first of all, I'm going to activate the inspector and let this cube cast a shadow. The ground will receive a shadow. The directional light I'll place it a little bit more up and towards the left, and it will cast a shadow. This one can actually go a little bit higher. And because our camera is here, I'd like the light to be here. I want the light color to be a little bit of a reddish color. And the ambient light, which is not coming from any particular direction, but basically from everywhere, this one should be in a slight blue tint. Now I can go back to my camera and zoom in a little bit. I'm going to place the camera way further up, rotate it so that it looks down on the cube. For that, I'm going to disable snapping. The white line that you see here is the center of the camera. And I think I'm going to place it a little bit further to the left here. For that, I'm going to change the transformation space so that I can move it freely in this X and C plane. Now it already looks a lot better. So this is what the scene now looks like in code. Every change that you see is made by the studio itself. Dialing these numbers in by hand is time-consuming and tedious. Just like the regular Svelte inspector, the Threlte Studio Inspector also allows you to jump to the position in the code where a particular mesh or object is instantiated. In this example, I want to rotate this mesh around the y-axis continuously. And to do that, I'm going to use the hook useTask that runs a callback on every frame. And this callback is given a delta, which is the time between this frame and the last frame. First, I will create a reactive variable using the state rune. Then I will update the value of this signal in the callback of useTask. Next, I'm going to create a property rotation y and use the signal rotation y for it. So this is what it looks like now. You can see that the cube is kind of floating, but to really drive the point home, I want to employ another component from the extras package. It's called float, and it does exactly what you would expect. You just wrap your mesh in it, and it kind of gives this floaty vibe and slowly moves an object up and down. So one thing I noticed is that the shadows have these jagged edges, and this is because the shadow map doesn't have the proper resolution. To change that, I'm going to select the directional light, which is casting the shadows. I'm going to select shadow. And inside of this, I have the property width and height of the shadow map size available. I'm going to change this to be 2048 by 2048. The shadow map has been updated. If I go back to the code now, I can see that the studio is also able to set these, what Threlte calls pierced props. So it pierces into the object and sets the properties accordingly. The Threlte Studio is not a Unity replacement or a full-blown, what you see is what you get 3D engine. It's a companion that you can use and customize to your liking. This, for example, is a custom extension that draws a bounding box containing all selected objects. This extension is a Svelte component itself that is passed to the Studio component we added earlier. It has access to the state and actions exposed by other extensions, as everything that the Studio comes with is essentially an extension. Currently, we are busy with making Threlte Svelte 5 ready. What you see here is already Svelte 5, and the Studio will actually be Svelte 5 only. But we're not ready just yet. Feel free to join our Discord or follow us on Twitter to get the news first. We can't wait to see what you build with it.
My
All
mouth
right.
was just like wide open. I'm like, this is incredible. And then the Svelte 5 drop, like, how is this Svelte 5 ready already? Like, you put all that work into that talk, build that studio, and then also make it Svelte 5?
Yeah. What if Svelte 5 changes? Who knows?
Yeah, then you got to go back and, oh, it's so problematic, like working with those early APIs. Yeah.
Yeah. All right. Next talk. I think you're up.
Yeah, I'm up. We have our sponsor giving us a talk talking about Convex. Tom Ballinger is going to talk about how Convex is a backend as a service product that offers a product-focused path for founders designing their infrastructure layer by letting them write their backend like they would write their front end. Instead of managing compute and architecting bespoke middleware independently from your product, Convex allows you to develop your backend in a parallel with thoughtfully designed client libraries. And I'm not a backend engineer, so I'm kind of excited to how I can make that easier for myself.
Yeah, let's check it out.
Hi, I'm Tom, and I'm going to talk about Convex Svelte. So this is a new Convex client for Svelte. You can install it today, npm install convex-svelte. And what is Svelte? Well, oh, you know that. What is Convex? Well, it is a way to extend reactivity from your reactive DAG tree, whatever, of Svelte atoms all the way back to the server and even all the way to the database. I'll say it again. This is a way to extend reactivity from the div or the span or whatever back through the other derived things in Svelte, but then often that's server state. What if that server state were also to update reactively? And what if that server state were always in sync with the database? So here I've got a simple Svelte app. I've got a layout that sets up Convex here and then a page. And when I use a query, I'm going to get a reactive view of some data in this query object. We can check if it's loading. This is all kind of Svelte query style. And then in here, I get to act on this data. What would normally be the end of our reactive graph, our reactive tree, our reactive DAG, we get a server function. And we pop over there, take a look at it. Looks like it is a query which just asks the database for everything in the tasks table. Buy groceries, integrate Convex, go to the park. If I look at my Convex view of that data that happens to be backing this view, I can update something. And we see this check mark appear here. And now let's change that query. Instead, we could say, well, these are the tasks, but I actually want to augment that data somehow. Maybe I want to join it with another table. Here, all I'm going to do is return tasks. Let's map over them task. Let's add another property here. We'll say everything that's in the task straight from the database, but then also let's add that the assigner was Tom. So this is just hitting home that this is arbitrary JavaScript here, and somehow talk later about how somehow we get a reactive view of this function. So now back in the page, we could be using the task.assigner. And now that's popping up here. Assigned by. Cool. Now this is code that runs on the Convex server. It's not running in the client. And that's a hint about how we're going to do this magical reactivity. Let's look at a little more complicated app. We've still got a single table here that we're displaying a view of, but now we've got some UI, it's a chat interface. I can send new messages. I quite like VS Code now. And you can see some state flowing through here. I've got some states. We've got the full version of use query where we need a reactive Svelte object that gives us the new value of whether what the words we want to mute are. So I can say, I'm just tired of hearing about Vim, filter those out. Gosh, actually it's Emacs that I've got enough of. Also, I just don't like the letter Z, not a fan. And our server function's a little more complicated too. Let's take a look at this. List now grabs the messages, does an in-memory filter where we remove the ones that have somewhere in them one of our mute words, and then return the messages reversed. So we have a nice chat interface where new messages show up on top. This is the built-in demo app in the Convex Svelte repo. So you can check it out, run the initialization commands, and give it a shot. People have been using Convex with Svelte for a while, so this library isn't necessary. You can see the syntax for normal JavaScript. Svelte can work with JavaScript. And it's not bad. It's just missing that use query hook that lets you say, I want a reactive view of this query on the server. Don't think about subscribing, unsubscribing, anything like that. This Convex client is written for Svelte 5. And that's not just because I was trying to be cool. I actually like Svelte 5 more, and I tried to do this about 6 months ago for Svelte 4, and I had some trouble. So I want to look at why it was easier this time around. One answer is it was prioritized this time. It wasn't just a side project I was just playing with. We decided it was time. We need to support the Svelte community. Another is I asked for more help. Gosh, the Svelte community has been terrific. Just in Discord, let's see, calling out 3 people that helped a lot. We've got Stocky, who sent a lot of nice playgrounds while I was trying to learn the primitives, how the runes worked. Stanislav was helpful. I got Ben to give me some thoughts on the library. But another thing is I truly believe that Svelte 5 is actually easier to learn. Or at least it was for me. That could be because I'm coming from React, and so I'm not used to some of the compile time things, and it's a little more explicit. It could be that there's just the one kind of reactivity. So when I was trying to build it before, I thought, do I need a store of stores? But then I'd also be looking at where I was using this and seeing the more compile time reactivity. And I had some confusion regarding these two. Thinking about the different kinds of reactivity between Svelte 4 and 5 also makes me think about how Convex's reactivity differs from Svelte's. So I want to talk about reactivity in Convex. I first will claim that everything that's reactive, all reactivity is about running your code every request animation frame, at least conceptually, right? If I could just write simple code that made my UI a pure function of state and just did that on every frame, and then I guess cheat a little bit because there's different kinds of state that I need to persist in the DOM, but basically I'm just building my UI every request animation frame. And the different kinds of reactivity are about how we optimize that. How do we get around the fact that we don't actually want to run this 60 times a second, 120 times a second? Different than game programming, right? Where you might say, yeah, absolutely, just have a one linear path. Go ahead and try to run that code 60 times a second. We would like to run less code sometimes. We'd like, if there's no interaction with the page, we'd like there to not be a lot of CPU getting eaten up. So when we look at the Convex code, we don't see signals. These functions run from top to bottom, and they're at least TypeScript tells us, they're just pure data. And TypeScript's right. This is just exactly what it says. This is just a array of message objects. And filtered messages is the same thing. So we don't have that. There aren't these signals in there to do this more carefully. So you think, well, is Convex just a polling thing? Is it just going to run this code once a second, 10 times a second, whatever, on request animation frame, right? And again, that's a reasonable mental model, but that's not what's happening with Convex. Another reactive system I've worked with is observable. And there we compile an expression out so that some of the variables come from other cells. So maybe that kind of compilation is what's happening here. But that's not what's happening here either. Instead, it's all done at runtime. In Convex, we run a function, see which rows were read from the database, and then track that. So no compile time at all, just run the code and see what happens. So looking at this code here, when we read this whole messages table, we are saying there is a dependency for this query function on that entire messages table. So this is more dynamic. There's no need to declare dependencies. But what about if statements, right? What if the first time you run a function, it accesses these database rows, but then another time you run it, it accesses some other ones? Well, if it didn't access them, then it's not part of the read set. But because the Convex runtime is deterministic, we know the next time we run it, that same if branch is going to be taken. Determinism takes some work. We've got to mock out math.random. We have to schedule the promises carefully. So this is happening in a custom, in a V8 runtime that's not Node. And as compared to something you could compile, say SQL, which lends itself really well to compilation, we can look at it and say, oh, I see that we're reading these things. This is more work, but the expressiveness of JavaScript is really worth it, right? Writing business logic in SQL is difficult. You get some of the same benefits that we have in Convex of code that runs inside the database, code that has access to the database, code that runs transactionally, but it's trying to write imperative-ish SQL that accomplishes business logic is tricky. Okay, but what about database rows that didn't exist before? So I run a function, it reads these 6 rows, and then I add a 7th row. That one wasn't in the set of rows we were tracking. Well, the way that we track rows is actually ranges of tables, maybe a whole table, maybe hopefully a region of that table, or a range on an index. So this is an interesting, different take on reactivity that produces something similar to signals where the level of the signal is the query. Each of these queries will be refired when necessary, and you can have dependencies in your front-end app on each of these queries. You could have many queries. Each one will refire only when the result to that function has changed. There are some other benefits of this model that are interesting. Part of extending reactivity all the way from a div back to the database is that we also get to extend the database consistency all the way up to the divs. So say you have code where this region of UI depends on database query, this region of UI depends on a different database query. If those were requested at different times, then those might not quite match. But hopefully whatever you're using to fetch your server-side data, maybe it fires mostly together. Maybe they're just a few milliseconds off, so it's fine. Right, it's just a visual anomaly. But maybe you have data that depends, so it's one piece of UI that depends on multiple database queries. It can be tricky that each of those database queries each of those results might be from a different logical timestamp. So you need to be careful never to kind of join across them on the client side, never to assume that just because you have a list of messages with user IDs, you'll be able to look at a array of users and find the right user in there. But because we have this kind of reactivity that goes all the way back, we can take the database transaction and say now we are at a new logical timestamp and provide a consistent client view. Consistent client views simplify writing front-end code because it makes writing a front-end less of a distributed system. Now, right? We can say, I asked for this data from the server, and I know I'm looking at this data and this data and this data all at this consistent logical timestamp. I think of reactivity as intimately related to caching now, right? In that if I don't have something that's reactive and it's my job to maintain a cache, say like in Svelte query, the cache of the server-side state, it can be, it's a tricky imperative problem to say, all right, now's the time to invalidate that cache. Oh, I know that I've changed this thing, right? I have made a mutation and I expect that will change something, so we need to go refresh it. And this logic applies to edge compute too. If you have a read replica somewhere, or you have something dumber, which is like just memcache sitting somewhere and you need to manually invalidate, or something in between. The convex approach is nice because we have a completely consistent cache and we can push that cache down to clients. That's sort of what we're doing with these use query hooks. But we can also populate some other kind of cache with that. So it's powerful in general with reactivity to not be thinking about manually invalidating caches. Instead, to have enough information to do incremental computation. Enough information to say, yeah, this is the current value because this is the current value of all the other atoms in the chain of reactivity. So writing this client has been really fun, but learning Svelte has been even more fun. I've, as I said, appreciated the Svelte 5 approach. It's meshed more with my brain. So if there's any kind of hesitancy for folks, understandable that change is frustrating, but from a newcomer, from my perspective, and again, mine sullied by React a bit, it really was easier to learn with runes. So thank you. Love to hear what you think of Convex, what you think of this library. I'd love help with this library, and look forward to see what you make.
And we're back.
Yeah, we want to say thank you, Convex, for sponsoring Svelte Summit. That talk was amazing, like the presentation, calling out the community. This community is so amazing, and I don't know if everyone really realizes that, but anyone in this community will be willing to help you out if you need something, and it's an incredible place. So
Yeah,
I
it's
appreciate
so
it.
welcoming.
Yeah, so thank you, Convex.
Yeah.
And Thomas.
Yeah, so who is going to try Convex after this? I know
Yeah.
I will.
They're getting tons
Look
of
amazing.
love in the thread too. Like everybody wants to try it. Everybody's sold. Like that was amazing.
Yeah. All right. Next talk.
Yeah, I think
Yeah.
you're up, actually.
That is true. Yeah. Yeah. All right. So next talk is called Kitbook. Easily build, document, inspect, and test Svelte components. It's by Jacob, and I'm going to butcher this name. Sorry, Bodoin. Sorry. So Kitbook picks up where Svenj left off. For those of you that remember Svenj from a couple of years ago, it was a project made by a guy called Rixo. Who also made like the original HMR hot module reloading thing for Svelte back in the days. So tangent there. It allows you to, so Kitbook allows you to easily document components in Markdown and develop them in isolation using iframes. It will include relevant context from your main app needed to make components work. So styles, internationalization, SvelteKit imports, but not anything further that you don't want, like database connections. It adds a viewer to your main app so you can select where you can select components similar to Svelte Inspector, and instantly create type-safe component variants from the current prop state of the component. Then you just add a few more variants, then edit a component, and watch your changes update simultaneously across all variants. So pretty cool.
Yeah, this sounds like Storybook a little bit. And like we've had a few of these over the course of Svelte, like come through. Book it from Scott.
Yeah, Book it.
Yeah.
There's one called like Vitebook.
Yeah, Kitbook. And I'm interested to see how this does it though, because if you can document alongside your components, that would be an improvement over what Storybook allows right now. So
yeah, let's give it a watch.
Hey, Svelte community, I'm Jacob, and I'm living in Taiwan studying Mandarin. Here I am with my Chinese teacher. I work on various language-related web apps, and to make my work easier, I built a tool called Kitbook that makes it simple to build, document, and test user interfaces in SvelteKit, and I'd like to share it with you. Let me start with a view I have that demonstrates why a visual mocking tool is needed. Living Dictionaries is a platform for small language communities to build their own dictionary for the first time. The dictionary entry page has many different possible states, as both editors and viewers come to the same place. We need a way to be able to easily mock state and test interactions on views that have a large variety of possible states. We have 4 levels of user access: visitor, contributor, editor, and admin. The main word or a phrase could be written in multiple writing systems. There are often multiple glossing languages, sometimes with their own special keyboards. There's a number of possible additional fields beyond entries and glosses I won't dig into. And as well, an entry could have multiple senses. We support 14 different user interface languages, 2 of which are right to left. Users can add multiple different types of media, or even a geopoint, and then you have differences between desktop, mobile, client-rendered, server-rendered. You get the point. You also have components and views that you want to be able to build, edit, and test in an easy fashion without having to change user accounts, change languages, make database edits, or find just the right page. You need a tool to build components in isolation where it's easy to mock state. And this includes pages and layout components, as they're just Svelte components with a special data prop, as you well know. Kitbook's goal is to make it as easy as possible to build Svelte components in the context of a SvelteKit project. So far, you've seen a bit more complex examples of a view. Let's scale things back and look at the basic functionality of Kitbook. At the core is the variant, a named object exported from a sibling variants.ts file with the needed props for mounting a component in its own iframe. You can go further and define specific viewports, set context, platform, and language settings, for example. But the basic variant is just an export with the needed props. Variants cover most use cases. Sometimes, though, you need some slot snippet content, or you'd like to create a composition of components working in tandem, like this document and picture component you'll see used by Kitbook's viewer later. This leads me to Kitbook's second core feature, the composition, which is a Svelte file using the .composition extension and an optional config property exported from the context module block. Now, the last of the basic features is that you can add a sibling markdown file to document while you build components, or you can just have documentation on its own, either way. Variants and compositions will follow the documentation when the files have the same names, except for when you specifically include compositions in the middle of the markdown using the foam extension for VS Code. As a side note, for those who happen to be building a library with SvelteKit, like Kitbook itself, or my Svelte Pieces library, the foam extension makes it effortless to wiki link between pages and ensure these wiki links never get broken. These links auto-populate, work in VS Code, GitHub, and of course in Kitbook. You can also alias them. Now, since I work on multilingual tools, I18N support is a first-class citizen. Just add your languages to the global Kitbook config, along with a function that tells Kitbook how to adjust the URL such that each language can be placed into the URL. As you view variants and compositions, they are server-side rendered and then client rendered. The change happens pretty fast, so you can set it to stay in the server rendered state if needed for inspection via a toggle. Or perhaps you're doing something like rendering HTML from a Svelte component for an open graph image generator, or you're wanting to compose an email and using Svelte and getting the HTML from that. In these cases, you always want it SSR only because the component.render function only works on the server. You can do that by setting CSR to false, and things will still live reload. Not HMR, but live reload. Or the opposite situation, you may have components that work in the browser only, and so you can set SSR to false to avoid getting a server error. Kitbook supports virtually free visual regression testing via GitHub Actions running Playwright automatically on all your variants. Composition support still to come. And then storing those snapshotted images in a Google Cloud Storage Bucket solution. It's nice in a small project, but in a large project with a large number of languages, it's a little bit slow for Playwright to take all the screenshots, even with test sharding. So in the future, I'd like to use VTest-enabled HTML comparison and not pixel comparison to check for differences between the main and your most recent push to a PR branch. And then only visually render components via the Kitbook when I'm reviewing as a human. That'll be much faster, and I'll switch to that method. But of course, the current screenshot method would still work in the future if that's what you really want, but I don't think it's quite as compelling. My visual checking needs are mostly not browser change related, but rather they're for team communication and bug checking to make sure changes that we ourselves made didn't change HTML that we don't want changed, just made the changes we do want changed, as well to quickly review what teammates are doing. Currently, the action will add a PR comment with changed images. But in the future, this will be adjusted just to be a few stats about what changes happened, and then a link to the page in the Kitbook that will display all the changed instances between the main branch and your current feature branch in one page. That way you can easily review them. I don't use it much, but you should also know that this pipeline enables custom Playwright component testing via the meta.test property of a variant, and I'm sure people are interested in the future VTest and Svelte testing library could operate the same way to get some interaction testing automatically accomplished on the variants too. So those are Kitbook's basic features. My favorite is how simple and powerful the variants are. The sky's the limit with what you can do with them. For example, in my language learning app, I can emulate delayed data from the database. This is especially useful for developing edge cases or situations that change really fast. Or even if you want to mock out an AI chat interface, that's super easy with variants. Now, I have to tell you about my other favorite part of Kitbook. It's that it's tightly integrated into and designed for SvelteKit apps. After adding the Kitbook Vite plugin and starting your dev server, you'll notice a new route /Kitbook was added to your routes folder. We can open that in the browser to go straight to your app's Kitbook. From here, we could search for a component, add a variant, add some documentation, or add a composition. There are a lot of features to make it easy to jump from Kitbook to your editor, and also from your editor or your app into Kitbook. It's part of your main app, kind of like Nuxt DevTools, so that it's easy to move from working directly in the app to working in the Kitbook. You'll also notice I forked the amazing Svelte inspector into a Kitbook viewer. Left click works the same with complete node modules avoidance, but right click will open a document picture window with the current component state. I can change state in the page context and watch it update, or I can take that and make a new variant from that state. Functions passed in as props are turned into simple console logs, as most likely they have dependencies that would not get copied into your variant.ts file. But the original function code is still there in a comment to help you create a mock function quickly. I can toggle between these variants in the viewer, but I actually want to dig in a little deeper, so let's jump into this component's Kitbook page in another tab. Add some documentation and yet another variant. I can double check how it looks in different contexts and call it good. The addition of Kitbook to your main app means there's no need to duplicate setup of i18n, CSS, or mock various SvelteKit imports. It all works because it's just another route in your app. In doing this, it's important to still retain the ability to make sure to keep components backend agnostic. All data and possible database operations should be passed in via page layout load functions. If you follow this principle, then I have notes in the docs about how to structure your app to ensure components are decoupled from the backend. So yeah, read the docs all the way through if you want to use Kitbook. You need to know about the various useful features, but I also want you to read the roadmap so you can be aware of the rough edges. Though the core functionality is stable, it's not the prettiest yet, as well as a lot of the convenience features like quickly creating files may have bugs. As you use it, consider cloning the repo next to your project folder and installing Kitbook like this so you can make improvements and contribute them back to the project. I'd love your help, and the roadmap can give you ideas of PRs that would be very welcome. Follow the repo releases to hear about new features, fixes, and general tips. That's all for now. Give it a try and let me know what you think.
And we're back. Someone in the Discord chat said another yoink. I like that. Every single video that we've seen, it's like, I really want to try this stuff. It's all really cool.
There's a lot of cool new libraries and stuff this year, or this season, I guess.
Yeah, this season. And yeah, we've been running that hackathon to try to get new libraries and stuff, but I feel like we're getting there. And with Svelte 5 coming out, we're going to need all of them to like be updated. And yeah, really excited.
Yeah. All right, next talk.
Oh, yeah, it's my turn this time. Like I totally did the same thing. Yeah, so now we actually have Paolo Riccuti, who is our This Week in Svelte, one of the co-hosts, and he has been helping out doing all of the threads in chat, and we appreciate everything that he's doing, talking about full stack testing. So the description for this talk is once upon a time, to test your application properly, you just needed to monkey patch. I love this word, monkey patch fetch. All the communications with the server happened through that, and it was a simpler time. But nowadays, Meta Framework shifted the line, and you own the full stack. This also shifted the line for where you should test your application, but things are a bit more complex than before. Follow me in this journey and learn how to test your full stack SvelteKit application. Let's hear from Paolo.
Yeah.
Full stack testing. Before we begin, a quick presentation. Who am I? I am Paolo Ricciuti. I come from Campobasso, Italy. You can find me on Twitter as Paolo Ricciuti, on GitHub as Paolo Ricciuti, and I'm a proud Svelte ambassador. I'm generally a nerd, and I work as a full stack software engineer at Matter, which is super cool because I get to work with Svelte, but also teach Svelte because we do workshop, but most importantly because we do team augmentation, which means that we work with you on your Svelte project, and we also teach you how to work with Svelte and stuff like that. So, let's begin. I know that you are scared because I just dropped on you the most fearful word in web development world, full stack testing, especially testing, but bear with me, and I know that you are already asking why. Now, if you are working on a library, you should definitely test your library, no point. But if you're working on an application, I would assume that it's still pretty good to test your application. So let's play a game. I will show you this, which is a diff from GitHub. And what I want you to do is tell me if this is a bug or not. Now, if you are following along on fullstack-testing.richuti.app, you can just click here or here to actually get to the page to vote. You can actually just go to this page or scan the QR code. And if Kevin is following along, he should have put like the result of the vote here, because I mean this is actually recorded, so I cannot show it to you, but I can enjoy to you to see the bar changing. You need to press yes or no if you think that this will introduce a bug or not. And so yeah, I will just give you a couple of more seconds. So will this introduce a bug or not? And I really hope that you voted yes, because yes, this is actually introducing a bug. If you want to react to a prop changing, you actually need to use derived. You cannot just use let trimmed name.trim. And I mean, this would never work with Svelte 4. So yeah, this is actually a bug. It was a pretty simple one. You can now click on next if you want to go to the next question. So let's move to the next question. This is a simple component. It's just a button with a user list. When you click user list, a user list will drop. And you added a Svelte transition because you want to do something cool. And now you're adding a Svelte transition.slide global to this. So will this introduce a bug or not? And I will give you a couple more seconds. And no, this is actually fixing a bug. Yeah, because the transition global means that even if the UL, in this case, is removed from the DOM, the transition will still play. While with a local transition, only if the LI is removed from the DOM or added to the DOM, the transition will play. Yep, next question. This is an interesting component. Basically, you just drop it in your plus page, plus layout.svelte on the root, and you pass it the page that the user are in. And basically, it's just an effect that send a navigator.send beacon, which is just a post request to the page, to this /analytics that contains the data of the page. So in the beginning, it was like this. You then thought, well, maybe I want some information on the user. So you added inside the effect a fetch call to get the user ID. You are also using a controller because you're a good internet citizen, and you're adding the profile to the beacon, basically. So will this introduce a bug? And a couple more seconds, and I really hope that you voted yes, because yes, this will introduce a bug. And the reason is because effects are synchronous by nature. So you cannot use asynchronous code inside them. You can actually do it, but you have to be aware of the fact that only the variables that are accessed before the first await will actually be tracked as a dependency. In this case, we are tracking user ID, but we are not tracking page anymore. That's a bug. Let's move to the next question. And please ignore that this could have been done with Svelte window. It's just for the sake of presentation. So there is an effect, and you basically remove the window.addEventListener inside the effect. You moved the listener outside of the effect, and you added the window.eventListener to that function, and then returned the window.removeEventListener. Is this a bug? I'll give you 2 more seconds from now, and no, this is not a bug. This is actually fixing a bug. You always need to clean up your event listener, otherwise it will stay there even if the component is unmounted. So let's move to question number 5, and this is one of my favorite. I can imagine the commit message for this to be like clean up code base and stuff like that. And the component is pretty simple. It's just an input, and you want a minimum of 10, like it's an input number. You want a minimum of 10. So on input, you're actually saying e.target.value as number. You're storing that in a new value, and then you are assigning to value between mat.max from new value and 10. This means that if new value is less than 10, you will assign 10 to value, basically. And again, ignore that this could have been done with mean attribute on the input. I will give you a couple more seconds for this, and I hope that you voted yes, this will introduce a bug. I know it's crazy, but basically what's happening is that if value is already 10 and you try to assign 10 to it again, effectively the value didn't change. And if the value didn't change, Svelte will not do extra work for you. Like, why should replace something that is already 10? But this also means that it will never say input.value equal value. And this means that if no one does that, when you click under, like click the keyboard with the down arrow, it will just continue go down. So yeah, obviously never do something like this, write a comment or use don't say please work, but yeah, explain why this is working. And the reason why this is working, by the way, is because you are changing the value of value before reassigning 10. So yep. Let's move to the last question. So you are importing locale, which is a store, and locales, which is a list of locales, and get system locale. And the reason why you're doing that is because you also want to add a way for the user to select the system locale. So when the user selects system locale, you add a button and you set locale to undefined, and then you change the current locale to handle the fact that can be undefined. So will this introduce a bug? I will give you again 3 more seconds, and I hope you voted yes. This will introduce a bug. And now I hear you shouting, what are you talking about? And the reason why this is introducing a bug is because the store was using another part of the application, and the other part of the application was sure that it will always be defined, and you're introducing a bug. Now, I know that this is kind of sneaky, it's kind of tricky, but it's exactly the point that I'm trying to make. Like, the more your application grows in size, the more it becomes difficult. Just like this wonderful screensaver from Windows 98. The more time passes, the more your application interconnect, the more grows in size, the more difficult it is to reason about. That's why you should test even your application code. So let's stretch out and let's start this journey into see how you can test your application in SvelteKit. But before we do that, a couple of things. One, 100% coverage is a lie. And I mean, this is true for coverage in general. Like, don't trust an application just because it has high coverage. You should not aim for a number of coverage because it's just a metric that will be gamed. So the thing that you should do is actually just test with your gut. So, and second, I will use opinionated tools here. This does not mean that you need to use exactly my tools. This just means that you need to find a way to do the same thing with your tools. Pretty easy, right? Now, let's move back in time to a place where people were starting exploring, fire was discovered, and like this beautiful painting were painted on the wall of the cave. And in this era, in the web development world, we used to build SPAs, or single page application. Now, in this era of single page application, everything was easier. Like for testing especially, it was very easier because the only way to access your data was through fetch. So you could just do something like this. Like if you are in testing mode, you just change window.fetch with a custom function that will return your mock data based on the URL and maybe on the init. But nowadays, we are in the era of meta frameworks. We are in the future. There is SvelteKit, Next, Nuxt, Remix, Solid Start, Quick, and by the way, can you tell which one I love? And this means that this was our situation before, where our line was between the front end and backend and data. And there was a single point where you could go to actually fetch the data. And this is changing because those are full stack frameworks. And so the line has shifted. And now you want to test your front end, you want to test your backend, you want to test their integration, and you want also to test your backend. And this means that the single point or where you need to mock is between backend and data. Now let's see what tools we're going to use, because there are a bunch of tools, and this is because we need to test different stuff. So we will use Playwright, SQLite, Drizzle, we will use MSW, VTest, and Svelte testing library. This is because, again, testing is comprised of a pyramid, probably, something like this, where unit testing is the smallest unit that you can test. You are just testing single functions, and those single functions take a value in and respond with a value, and you are just testing that your expectations are met with those functions. Then there is component testing, and I know sometimes, like, someone could say it's not a component, it's actually integration testing, and I might agree, but I think in application land, what do you want to test is actually your components, because that's the part that probably integrate with your code. So that's what the other thing that you want to test. And then there is end-to-end test. This is the beefy guy, like this is the complex one, but also it's the most important, in my opinion, for application, because this is where we are testing the user flow. This is like we are mimicking the user flow, and this is where you can very much catch nasty bug. So what's the simplest way to get started on this? The simplest way is just tick those two boxes. If you tick add Playwright and add VTest, your Vite config will change a bit. So instead of importing define config from Vite, you will import define config from VTest/config, and you will also have this test include. And this just means that every file that ends in .test.ts or .test.js will actually be tested. We actually be run for test. And this is an example of a unit test. You're importing my function, you import this helper function from VTest, like eat, describe, expect, and you can define your test like this. So you describe what you are testing, and then you start writing your test, and it reads like English. It works as expected. Obviously write better than this, because I'm just lazy in this case. But then inside the test, you should have a 3-point, basically, the setup, where you create all of your variables and stuff like that, the act, where you actually call the function, and then the expectation. So when you say, in this case, I want my result to be defined. Again, unit testing is pretty straightforward, pretty simple. Let's move to something more interesting. How can you test component testing inside SvelteKit? You need to install something. You need to install testing library /svelte and testing library /jestom. I know that we are using VTest. Don't worry, install jestom. And also you need to install HappyDOM. HappyDOM is a library that basically mimics the DOM, but in Node environment. You can give it a string and it will render the DOM, and you have access to the DOM object model, document object model inside Node. And given that you're running in Node, we also need to change a bit inside the Vite config. Now, the define config is a function that takes in a parameter, in this case mode, and returns an object. And when mode is equal to test, we want to do resolve condition, and we want to add this browser condition here. And this is basically telling VTest that when it's running your application, if mode is equal to test, you actually want to run your application just like if it was a browser. And this basically allow for example, functions like onMount to actually be defined, because otherwise on Node, onMount does nothing. So that was a problem. Do it. The other interesting bit is these setup files. These setup files is very important because is these 2 lines of code here. You can actually do other stuff, but those 2 lines are very important because these will actually make sure that every time you render a component inside your component testing, after the test finish, that component will actually unmount. And this is actually adding TypeScript stuff, for example, and expectors. So the fact that you can do expect greet to be in the document is actually something that comes from this library. So you definitely want to add it. And then you can test it just like a unit test with VTest. you import the same variables like describe, it, expect. You import render from testing library /Svelte, and this will allow you to import the component and render the component. And after this, what you get back is a series of functions that you can query the document for. So in this case, I am just checking that after we render that component, we actually have a text Svelte summit inside it. So we are expecting that greet is in the document. One important bit, you need this. You need to specify your vtest environment to be happy DOM, otherwise there will be no DOM inside this. You can actually do it globally inside your vit config, but I prefer doing it inside my files. Now, this is component testing. Let's move to the big beef, right? The end-to-end testing. And if you are just using fetch on the server side, you are pretty much good to go with MSW. MSW, it's a wonderful library. It's called mock service worker, and it allows you to mock your data on the server or on the client. And it's used by Microsoft, by Google, like a bunch of Adobe, like really, like it's the industry standard. How to use it? Very simple. You can install it, obviously, pnpm install MSW at latest. And if you have these inside your package JSON, where you're specifying where MSW needs to put the worker, the service worker that it will use to mock your data. In this case, for SvelteKit, you really want to be in static because this needs to be served from your server, and it's a static asset. So you really want to be there. And once you do that, if you do npx msw init, it will create the service worker for you. And after you've done that, the only thing that you need to do is define your handlers. And so one way to do it is you can import HTTP and HTTP response from MSW, and then you basically define an express like application. Like you basically say that HTTP dot, you have all the verbs, so you can mock a get request, a post request, a all, that means whatever you want, and then you specify what URL this needs to mock, because obviously different URL needs different mocking. And inside here you have the function, and the function actually receive everything you need. Receive cookie, parameters, which is this kind here, like this is a parameter, an ID, and the request. The request is actually a spec request, like is the request from browsers and Node. And so you can, for example, create the URL, get the search params, and you return an actual response, like the response from the spec. So pretty cool, and you can return whatever you want. Like this is an HTTP response helper to like return text or JSON or whatever you want, really. And after you have done that, you have defined all of your handles, you can import those handlers both on the client and on the server. That's the beauty. Like you literally are using the same handlers on the client or on the server. And for the client, you want to set up the worker with those handlers and export it. For the server, you want to set up the server and export it with those things. And to use them in SvelteKit, what you want to do is you want to import your worker in hooks.client.ts, and if import.meta.env.mode is test, so if we are in test mode, you want to await the start of the worker so that the worker is mounted before the page is rendered. And if we are on the server, we want to only do that if the mode is test and start listening. And the best part is that given that you're doing this, if you are inside a mode that is not test, this will not be there. And if this is not there, this is not needed, and it will be shaken away. The last thing that you need to do is update your playwright config, which also comes from when you tick the playwright thing inside Svelte, create Svelte. And in this case, you want to build with mode test and preview with mode test so that these actually work. And this is actually unrelated to MSW, but it's something that I constantly do. Pipe your standard error and standard output because you will probably need it. And then you can write your first end-to-end test. Like you It's very similar to vtest. You expect, you test, and then you can literally destructure a page where you can navigate. So you can do await page.goto, await expect, and then you can get basically the same thing. Like you can get by role, get by text, get by even a CSS locator. Very, very, very cool. You expect this to be visible, and you basically can navigate away. You can click around, fill forms, and stuff like that. But this is the happy part. Like this is if you only have fetch calls inside your application. If you have a DB, the things change a bit because you need to do a bit more work. Now I'm using Drizzle as my ORM. So to set up Drizzle, you can just do pnpm I Drizzle ORM and libsql client. This is the client for SQLite. And you can do pnpm I DrizzleKit -d. It's a companion library for Drizzle. And once you've done that, this is basically what you need to do. You can create a file where you export your DB handle. You can create the client, and in this case, I'm just using a file. So it will literally create a file next to my process named mydb.sql and put everything there. But obviously, this can come from an environment. It can be Turso, for example, and stuff like that. And then you want to create your tables like this, and you can import SQLite table or text, and you create this export const users. And once you have these, what you can do is with Drizzle, you can actually run your migration. So if you run pnpm DrizzleKit generate SQLite, this will generate a series of SQL files that will bring your database up to date with your schema, which is super cool. And then you can use TSM, which is just a node for TypeScript file, basically, but you could use ban, or you could use like node migrate.js, and it will work the same. And this is our migrate file, where basically we are importing the migrator from Drizzle, and then we migrate the DB. Oh, I forgot to import the DB, sorry. We await migrate, telling that the migration folder is .drizzle. And so we also export this, and you will see why later. And this is just the Drizzle config that you also need to write. And everything is in their documentation. So it's pretty easy to do. But now what we can do is we can create a utils file. And these utils files, in my case, is just re-exporting all the schemas for the moment. And I'm importing the schemas inside a file that I set up, like this is a fixture.ts file. I'm importing the schema, I'm importing the DB, and then I'm importing test from Playwright. And what Playwright allows you to do is you can extend your test function. And by extending your test function, you can basically tell that the test, if you remember, we were destructuring page before. After we do these, basically you can create those functions here, and then you can also destructure DB or destructure schemas. And this is pretty cool because basically now every test can destructure DB, and the DB is actually the thing that you pass to this use function here. And the best thing about these is that those are called fixtures. Basically here, before the await use, you can set up your database, and here you can clean up your database. So in this case, we are like, it's not always needed, the init and the cleanup, but it's nice to know that you can do it. And so now what you can do is, instead of using test from Playwright test, you're using test from your fixtures file, and you call text. This is literally the same, but now you can destructure DB and schemas. And so before I navigate, I can, for example, insert something into the database. In this case, I'm inserting a name, a user with the name Paolo, which is me, by the way. There's only a slight problem with this, is that we actually did not clean up the database. So every time this test run, the database will have a new user inside. And this might not be useful because you want your DB to start fresh for every test, right? So the way to do this, you can add this resetDB function from the utils, and this is explicit for SQLite. This is a way to basically clean up your DB without closing the connection to it in SQLite. And then we migrate away again so that the DB is back to be in the right shape. And that's why we're exporting do migrate. And obviously you can do the same with Postgres or MySQL. So yeah. And so now we can get the resetDB inside our fixtures and reset the DB every time we begin a test. And we can even reset the DB after we use it so that it's always fresh. Now, I already hear Kevin pointing his finger to the clock because it took way longer than I was needed. So the last thing that I want to do, I want to thank you for listening, and I hope that you learned something, and I hope that this made testing a bit more approachable for you. Thanks for watching.
Yeah, I don't know about that. I'm kidding. It was a great talk.
Just a little over, but it's totally fine. That was an amazing talk. I think everyone learned a lot about how to test between your backend and your data.
Yeah, like it went through all different strategies that you use to test the different parts. Great talk. All right, we're here for the final talk. Brittany, are you ready?
I am ready, and I think everyone in the chat is ready. We've been hearing the chants already, so.
All right, so obviously this next talk is by Rich Harris. You might know him. He's the creator of Svelte. And the talk is called What You Can Do for Your Framework. Svelte 5 is coming, and we all have a part to play.
Oh, hey, I was just crushing some rings. All right, let's talk about Svelte 5. A lot of you have been following development very closely. Some of you have even YOLO'd it into production already, which God bless you. But some of you have probably been like, you know what, I'll deal with that when the time comes. Well, the time is coming. We're not there just yet, more on that soon, but there is light at the end of the tunnel. And so to get everyone on the same page, I'm going to quickly run through some of the biggest changes. The first thing I want to draw your attention to is the output of the compiler. In Svelte 4, if you have a hello world component, it generates all this code. And as you start adding state and logic and behavior, it starts to grow at a fairly rapid clip. And the generated code is pretty hard to follow. It's not a problem exactly, but it hints at the complexity of the Svelte 4 design. And it leads people to ask, does it scale? Now, the same component in Svelte 5 is much less code. It's much simpler, and it stays that way as we start to add more stuff to our components. This isn't just a cosmetic change, it reflects the fact that Svelte 5 is just much more tightly engineered in every respect. Here's a nice example of that. Components are just function calls. We're calling this counter function directly. There's no create component counter or anything like that. By getting rid of that indirection, we make the output really easy for tooling and JavaScript engines to optimize the hell out of. Another huge benefit of this overhaul is that the codebase is much more approachable for contributors than it was before, and it's going to be a lot easier to add new features. So your Svelte apps are going to be smaller. They're going to be more robust. They're going to be faster. Does it scale? Yeah. It scales. Now that's all good news for your users, which is the most important thing. But Svelte 5 is also good news for you, the developer, because there's a boatload of new stuff and we're going to talk about it. The most obvious change is runes. Just like in Ragnarok, runes are magical symbols. In Svelte, the magic is reactivity. You declare a piece of reactive state with the state rune, and every change of that state causes an update. This works for objects and arrays too, so I can add an item to a list with array.push, and if I modify a single property, only the things that depend on that specific property will get updated. I can create derived state with the derived rune, and I can use the effect rune to run imperative code like updating a canvas element. Now, a side note, the effect rune isn't something you should be using often. It's really more of an escape hatch than anything. So if you find yourself reaching for it often, think about whether there's a more declarative approach that would fit better. The really cool thing about runes is that they're not just for components. You can use runes in .svelte.js and .svelte.ts files. So whereas in the past you might have wanted to refactor some code into a utility module, but then realized that you were going to have to rewrite everything to use stores, that's no longer true. If you've used stores to do anything complex in the past, you're really going to appreciate how much simpler your code gets with runes. Essentially, Svelte is no longer just a component framework. It's a language for describing reactivity that dovetails seamlessly with JavaScript and TypeScript. There are many improvements beyond runes as well. Slots were always a bit confusing and messy in Svelte 4. Weird syntax, lots of restrictions on how you use them, no type safety. Don't even get me started on the let directive. In Svelte 5, we have snippets and render tags. You can use these within components to define reusable chunks of markup, and you can pass them between components as props. Another big change is around events. In Svelte 4, you add a click event listener to a DOM element with on::click, but in Svelte 5, we get rid of the colon. They're just like any other attribute. This makes things much simpler when dealing with component events. Instead of doing the whole create event dispatcher thing, we can just use props. As well as being a lot easier to use, it's a lot easier to type. Speaking of which, Svelte 5 supports TypeScript natively. TypeScript was supported in Svelte 4 via a preprocessor. If you add lang=ts to your script tag and configure your bundler appropriately, then you can use TypeScript syntax, but not inside your template, which is particularly annoying for things like inline event handlers. In Svelte 5, it just works. TypeScript goes into the compiler, JavaScript comes out. You do still need to opt in via lang=ts. We have reactive versions of the built-in map, set, date, and URL classes. If I edit path name here, href updates and vice versa. It's really easy to build your own reactive classes because you can use the state and derived runes to define class fields. This is a really great approach to domain modeling. If you're one of these people who thinks classes are bad, it's probably because you are listening to some washed up thought leader. As long as you avoid inheritance and keep things self-contained, classes are really cool, and Svelte embraces them wholeheartedly. We're just a classy framework. Style tags also got an upgrade. You can now use CSS nesting syntax inside your components, still taking advantage of Svelte's style scoping and unused CSS removal. It's also much easier to create global styles. If I want to target some elements inside an HTML tag, I don't need to repeat this stuff over and over again. I can just put it all inside a global block. So there's a lot of new stuff, and I know what you're asking, when can I use it? Well, I won't bury the lead any further. Svelte 5 is now in the release candidate. Actually, you know what? I will bury the lead a little further. This announcement feels a little flat. Needs a little something extra. There's only one man who can help. Bear with me a second. Hey, Puru.
Hey, Rich. How's it going?
Good, man. It's been too long. So listen, I need your help. I'm doing the Svelte 5 release candidate announcement, and it needs a little something extra. Need some of that Puru magic. Do you think you could hook me up?
Yeah, dude. No problem. Send it over. I'll see.
All right, I'm sending it over now. You got it?
Okay, I got it. Let me see. and this should do the trick.
Awesome, here goes. So without further ado, Svelte 5 is now in the release candidate phase. Hey, thanks man, this looks great. You really came through.
No worries, man. Glad I could help. And a big congratulations to the team for making it to the RC. Exciting times ahead.
Wait, how are you doing this? Well, that was weird. So what does this mean? It means that in terms of API design and feature set, as far as we know, Svelte 5 is done. I say as far as we know because we can't be certain until it ships, but if you start building with Svelte 5 today, we don't expect breaking changes between now and the stable release. It also means that all of the big, obvious, how could they let this happen bugs are fixed, and the stuff that's left is mostly edge cases and polish. It does not mean it's ready for production. I know that when I say that, a lot of you go, la 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 la, we can't hear you. But if you do take it to production and things break, there are no refunds. So how do you get started? Well, if you want to try it out in a new project, you can run npm create svelte at latest, and it will give you the option to try Svelte 5 in a new SvelteKit project. If you have an existing project, you can npm install svelte at next, and you should be good to go. If you're using the TypeScript preprocessor, feel free to remove that. If all goes well, things should continue to work. Once you've done that, you can start migrating your components to use the new features. And that migration is what I want to spend the rest of my time talking about. We've gone to some honestly quite absurd lengths to make sure that code written for Svelte 4 will work the same way in Svelte 5 with a tiny handful of minor exceptions. And we're working on a tool for automated migrations that you can experiment with today. It's right here in the playground. But it's not going to be enough because this is ultimately a collective action problem with some tricky dynamics. We've seen this with other frameworks and even entire languages. The incentives not to upgrade can be stronger than the incentives to upgrade. And so we find there's a tension between application developers and library developers. A really good example of this is ESM versus CommonJS. As most of you probably know, CommonJS was the de facto standard for writing modular JavaScript for many years, and it's still the most common format on NPM. But now we have a real standard, ESM, and it has some important advantages over CommonJS. So much so that authors of new libraries overwhelmingly prefer it. But here's the rub. If your project is ESM, you can use ESM dependencies or CommonJS dependencies. But if your project is CommonJS, you can only use ESM in certain scenarios. It's got a little bit better in Node 22, but there are some caveats. The essential dynamics remain. What this means is that if you're building a library and you distribute it as ESM, a lot of people won't be able to use it. So as a library author, you're incentivized to use the old format instead of the new, better one. Some people will distribute both ESM and CommonJS in the same package, but that involves extra work. For application authors, the easiest thing to do is nothing, just keep using CommonJS. After all, switching involves extra work. So the incentives are in conflict. Both sides quite reasonably want to avoid doing extra work, and the result is that the rollout of ESM has been incredibly painful for the ecosystem. Unless you're using SvelteKit, of course, because we saw this coming years ago, and SvelteKit projects have been ESM first since day one. Unfortunately, the same dynamics that I've just described also apply to Svelte 4 and 5. If you're building an app with Svelte 5, you can use dependencies built for 4 or 5, but if you're building an app with Svelte 4, you can't use dependencies that need Svelte 5. So once again, library authors are disincentivized to adopt the new stuff, and that could be a real problem because eventually, in Svelte 6 or 7, we will need to drop support for some of that old stuff. So how do we solve this collective action problem? Well, the answer is by taking collective action. We need to pull together as a community. Ask not what your framework can do for you, ask what you can do for your framework. For application developers, your task is pretty simple. We need you to update to Svelte 5 as soon as you can once we reach a stable 5.0. If you want to start experimenting with the release candidate on a branch today, that's even better as you'll help us uncover any last bugs and design flaws. You don't even need to update your components. That can happen gradually over time. All you really need to do is update your package.json. If you're currently on Svelte 3, I do recommend updating to Svelte 4 first by following this migration guide. That's something that you can do today without waiting for Svelte 5 to come out. For library authors, the first thing I recommend doing is updating your peer dependency on Svelte. If you currently depend on 3 to 4, make that 3 to 5. You can do that in a patch release without any other changes, and people who have updated to Svelte 5 will be able to use your package without getting a bunch of peer dependency warnings in their terminal. Once you've done that, it's time to create a Svelte 5 version of your library. This is a breaking change, of course, so it needs to be a semantic versioning major release. If you plan on continuing to support the old version, then you should create a branch at this point so that you can continue working on that branch and cutting releases from it without interfering with the new version. Make sure that in the new version, your package.json specifies a peer dependency on version 5 and not on older versions. You could release it just like that, but if you're going to do a major release, then now is the time to make any breaking API changes. For example, getting rid of slots and replacing them with snippets, and replacing any component events created with create event dispatcher with callback props. Once you've done that, you can release your package to npm, pour yourself a drink, sit back and relax, knowing that you've done your bit. Aside from app developers and library developers, there's a third group that's essential to making this migration a success, and that's the educators. If you're someone who creates content about Svelte, then people are going to be looking to you to understand how to make best use of the new features. We can do this. It's a challenging moment for any project, but this is our framework, and if we all pitch in, I'm confident it's going to be a huge success. I'll see you all soon. Peru, stop it!
Wow.
Those two in there
Was,
kill me.
so, yeah, it was really fun.
Oh,
I don't know. Oh, what is happening? Peru is everywhere. I don't know what's going on.
in the world.
It's crazy. Oh, whoa. Is he upgrading the confetti package? I don't know. Wow. Sorry.
Oh, nice. But yeah, we're in RC.
Yeah. Stable.
I feel like flashbacks to 2022 in the in-person conference with the confetti and the RC release.
Yeah, the RC for SvelteKit, right?
Yes, for SvelteKit, yeah.
Right. So basically that's it for the conference.
It's amazing how far we've come in 2 years. Just
yeah,
to think about that.
it's crazy.
Yeah, that was an amazing conference, and it's great.
Hope everyone had fun and enjoyed all the talks. I sure did. They were really nice. Yeah, and as a last few words, I wanted to again thank our sponsors, Convex, for partnering with us. Also, great talk, and Monogram for continuously sponsoring Svelte Summit every time, which is awesome.
Absolutely.
And with that said, I think
want to
that's
thank
it.
Paolo again too. Like, thank you for sitting in the background and being helpful with the threads. That was super helpful.
Yeah,
and thank you for the community. We had overall like very nice interactions and comments. So thank you.
Yeah, and we will see you in the fall.
Yeah.
All right. Bye, everyone.